everyone, myself Nidhi Ghetia from Faculty of Pharmacy, Dr. Subhash Technical Campus. Okay, so here we study our subject that is Pharmaceutical Organic Chemistry 1. That's called that is BP202 TP. Okay, so today we start our fourth chapter, new chapter that is Conjugated Dienes. Okay, so today's our study of the content, that is introduction of the dienes, then nomenclature of the dienes, then classification of the dienes and preparation of the dienes. So here first introduction. So what is conjugated dienes? A dienes is a hydrocarbon chain that having two double bonds having in a structure. Okay, so dienes are the hydrocarbon chain. Hydrocarbon means the what? So hydrogen and carbon are having in a one structure, that's called the hydro and carbon. Okay, hydrocarbon chain that's having a two double bond in their structure, so that's called the dienes. Okay, so these double bonds are may or may not be adjacent to each other. Okay, and then general formula of the dienes, that is CnH2n -2. So this is a general formula of the dienes. And then dienes are isomeric with alkynes, but their properties are different from the alkynes. Dienes and alkynes are isomer to each other, but their properties are totally different from the alkynes. Okay. Then nomenclature of the dienes. So first identify the longest chain of a chain that containing both carbon with double bond in their compound. Okay, so first identify the carbon numbers and double bonds of the their structure, and then the given lowest possible number for the location of the carbon with the double bond and any other functional group present. Okay, so here three examples, that is first one, that is a 1,3-butadiene. It also having a two double bonds in their structure, 4 number of the carbon and two double bond in their structure. Then pentadienes, so it's also having a two double bond and 5 number of the carbons. And then isoprene, that is a butadienes, 2 methyl butadienes. It having a 4-5 carbon, but in iso position, one methyl group it attach in a iso position with double bond, so that's called the isoprene. Okay, now we study the classification of the dienes. Dienes are generally classified in three categories. First one, that is a conjugated dienes, depends on the double bonds. Okay, so classify in depends on the double bonds. First one, that is a conjugated dienes. Second one, that is a non-conjugated dienes. Then third one, that is a cumulated dienes. Okay, so first one, that is a conjugated dienes. That conjugated dienes is dienes in which double bonds are separated by the single bond. Okay, two double bonds are separated with one single bond, that is a conjugated dienes. So here two examples. First one, that is a 3,5 octa dienes. 3 number position and 5 number position having a double bond, and 8 number carbon ring. Okay, hydrocarbon chain, 8 carbon are present in that structure. Then second one, that is a 1,3-butadiene. So here 1 carbon and 3 carbon having a double bond, so this structure that name is a 1,3-butadiene. Okay, then second one, that is a non-conjugated diene, also known as a isolated dienes. Okay, so dienes in which double bonds are separated by the one or more single bonds. Double bonds are separated with one or single bond, more than single bonds, that's called the non-conjugated dienes. Not one but more than single. Okay, two or three single bond are separated to two double bonds. Okay, so this is a non-conjugated dienes. So 2,5 heptadienes, so 2 number position and 5 number position having a two double bonds. Okay, so this is a heptadienes, 2,5 heptadienes, 7 carbon are present. And then 2,4 pentadienes, so first number position and 4 number position separated with the two single bonds, so this called the pentadienes, 1,4 pentadienes. Then third one, that is a cumulated dienes, also known as allynes or cumulants. Okay, so dienes in which two double bonds connected to similar carbons, two double bonds are attached with the one similar adjacent carbon, that's called the cumulated dienes. So here two examples, that is a 2 propa dienes and then 1,2 butadienes. One carbon having a two double bonds, so that's called the cumulated dienes. Okay. Now we study the preparation of the dienes. So first one, that is a retrodial aldehyde reaction, that also called the pyrolysis of the cycloalkane. Okay, when cyclohexane vaporized in a vapor is passed over the heating nichrome and alloying and making the 1,3-butadiene is produced. Okay, so here first we take the cyclohexane. Okay, cyclohexane are in vapor form in the presence of the nichrome and making the 1,3-butadiene and one breakdown of the cyclohexane and making the 1,3-butadiene and one ethylene molecule. Okay, so this is a retrodial aldehyde reaction, also called as the pyrolysis of the cycloalkane. Second reaction, that is a catalytic dehydrogenation. So in this reaction, 1,3-butadiene is prepared by the catalytic dehydrogenation of the butane or 1-butene or 2-butene. Okay, so here first reaction, that is we learn the butane. Okay, so first we take the 1-butane and reacted with a Cr2O3 and AlO3, aluminium oxide and chromium oxide. Okay, so that making the 1,3-butadiene, and with a 2-butene and 1-butene, Ca2PO4 and Ni3PO4 and then reaction further and making the 1,3-butadiene. Butane or butene generate the one, that is a butadiene. That intermediate catalytic agents are the different. So this is the catalytic dehydrogenation of the dienes. Okay, alkanes or alkenes. Okay, then generation of the dienes. Then third one, that is a dehydration of the butane 1,3-diol. So acid catalyzed dehydration of the butane 1,3-diol gives the 1,3-butadiene. So here first we take the butane 1,3-diol plus in the presence of catalytic agent as a mineral acid as a catalytic agents and making the 1,3-butane double bond are generated in 1 or 3 position, and so that's called the 1,3-butadiene and 2 water molecule are removed. Okay, so this is the third number reaction preparation, that is a dehydration of the butane 1,3-diol. Then fourth one, that is a dehydrohalogenation of 1,3-dichlorobutane. So when 1,3-dichloro-3-methylbutane is reacted with the alcoholic KOH, then isoprene is formed. Okay, so here first we take the 1,3-dichloro-3-methylbutane and in the presence or reaction occurs in the presence of the KOH and higher temperature, near about 573 degree Kelvin. Okay, then making the 573 Kelvin temperature. Okay, then making the one isoprene CH3 are attached in a iso position, so that's called the isoprene, and 2 HCl are removed. Okay, so this is the preparation of the dienes. So thank you to all.